Welcome to episode 5 of the PM Blend here at Atlas Press Metals. I'm Mark Powell. The strikingly handsome gentleman to my left is Joe Pfingstler.
Thank
Joe?
you. Thank you very much.
Yeah, you're welcome.
Appreciate it.
And we're excited to have you here for episode 5. We've got some great guests with us today. Doug Haynes, Tom Pfingstler, and Phil Parks, all very important parts of our team here at Atlas Press Metals. And today we're going to discuss getting your PM manufacturer involved in the design process early and what are some of the advantages of doing so. Gentlemen, thanks for joining us today. Nice to have you here. Yeah.
Great.
So, Joe,
Mark?
what do you think?
Well, let's kick her off.
You want to get her going?
Yeah, go for it.
All right. Let's jump right into it here. Let's talk about some of the challenges that can be avoided when getting your PM manufacturer involved early in the design process.
Well, starting out when you first receive a model or a drawing from a customer, they don't really understand the powder metal. Most of them don't understand the powder metal application. So us helping them early on helps develop a part that suits them for their needs, but also suits us for PM manufacturing, which helps out in the long run, saves money and time.
Yeah, some of the other things would be with the tool design, with the cost of the tools, getting that part design right, getting that tool design right the first time is important so that you're not making changes 2-3 months down the road to changes that should have been made in the beginning. So from a tool cost standpoint, it helps as well.
Yeah, that happens mainly when you're dealing with conversions type things too, with people that aren't familiar with PM.
Mm-hmm.
So,
and most of the time the customers have short time, short leads of time. They need to get parts done as soon as possible. That really knocks down on how many times you have to go back and forth after the initial print's already done. So it makes a big difference.
and it's not just design; it also includes material as well. So you get a lot of customers that maybe aren't even familiar with the PM materials.
Right.
Or getting, depending on the application, the proper finish, whether they want it plated, whether they want it steam treated, all those things that are discussed up front, or when we have conversations with customers. I know Joe is big on that. He brings that up to them right away. What atmosphere is this part going to be in, so that we can get the right finish for the customer as well.
And that kind of leads into some of what you touched on, Doug, with the tooling, leads into how that early involvement affects the overall cost, and how that can save money. So maybe we talk about what some of those cost savings can be.
Well, when Phil and I being the tool designers as well, when we're looking at a part, we're not only looking at something that we can manufacture, we're looking at what's the tool going to look like, and where can I avoid issues or a design that would not be robust. So those are kind of things that are in the backs of our minds, with all the tool design experience that we have. So, we're looking at the part from that aspect.
Which would save scrap for one, right? So
Or poor tool life, where you're gonna have a tool that's gonna crack frequently, or the face details would chip frequently that you're constantly going to be redressing, or having to make a new tool. So we're trying to avoid those situations up front. We're trying to make a good, robust design for the customer, but also have a good, robust tool design.
And a lot of times we don't know the application of what the part's going to see at the customer. So working with them sometimes eliminates the amount of tools we actually need. So if we can work with them on a design, maybe we don't need to have 2 or 3 bottoms and a punch, or a bottom, or two or three tops punches also, which reduces the cost of the tools.
And keep in mind, it goes along with everything they're talking about. Most customers aren't familiar with powder metal. Mm-hmm. So we're having to guide them away from a process that they may be familiar with. Maybe they're stamping people, or they're casting, or they're machining people. Our process has different needs. And so where it might be common to do in a casting, draft angle or something like that, that kills our tools and kills our production. So you have to get to them early enough so that they don't design for that when we're trying to avoid that.
Yeah, and I think part of our early involvement, Joe, and I know we've discussed this in earlier episodes, but it's probably worth mentioning today, is the PM 101 that you offer is oftentimes that very first involvement we have where, we're trying to educate them on the front end before we even get into the design phase, or while they're thinking of, hey, we have a new project coming up, we don't know a lot about powder metal. Your PM 101 is a great way to get that first introduction.
Right. And that ideally works best when they have more than just engineers in there, that they have some of their production people and quality people involved, so that they begin to have an understanding of the nuances of our process and what's important to us and what's not. These guys are going to try to guide them to a good, robust design. That's our intent. And so if they're engaged in that, in the PM 101 and or on any of our conversations, we've been on a lot of calls that we are heavily involved in that side of it, because we want them involved in that, telling us exactly what the needs are. Because a lot of times what will happen is, as Phil mentioned, they'll send you a model. Well, that shape's great, but what's it going into? What's it interacting with? What's the function? How's it being assembled? All of those things come into play to tell us, do we have enough built in to cover and meet their needs in those cases?
Mm-hmm.
Yeah, I mean, there's been many times we've been in meetings already that the design turned out nothing like the initial model. Working with them with what they need for their part, what it has to function has to be compared to what we can make, makes a big difference.
Yeah. Why don't we talk about success stories? I mean, do we have any? I know we can't get too specific on certain success stories, but do we have some examples that we can give that, maybe recent history of us getting involved early and, getting a customer to a really good, robust part?
Yeah, so there's a part we worked on recently that, it was a lot of times when a part's made by another PM manufacturer and our customers looking to move that part for one reason or another, it's nice to look at the part, be able to, cut up the part and see the successes they had or the issues that they may have had, because then we'll go to work with the customer, and if the part's having cracking issues, we'll say, hey, this is why, and then we can kind of work on a solution. And we did that with a part recently, and it turned out really, really good. The other thing with the part was there was some fill ratios that were kind of out of that weren't balanced quite so well. We were trying to mold too much on one punch, as far as the face details go, and they were really over densifying in some areas. So working with the customer on that and having them understand what I meant by fill ratios, a spin-off of Joe's PM 101. Right. There's some PM 101 that goes on the fly as well.
Yeah, absolutely.
So that part turned out well. Had a lot of good conversation with the customer. Like you said, it wasn't just one call. There was several emails and several calls until we got things ironed out. But
lots of model versions.
Sure.
Yep. Yeah. Any other examples, Phil?
There's a customer we're still working with today. We've gone through some small design iterations with them, but we're supplying not just components, but we're actually assembling the components together, which we won't be doing in production. But we've come a long way with them, not just making the parts, but doing testing with them and helping them through their process of the part working for their application. Mm-hmm. So we not only did we get with them as far as the tooling and stuff like that, and that's just part of it, but we've used our engineering services to help them produce a part that works for them. So we've done a lot of work with them with that.
Yeah. And Phil, you had said it early on. I mean, you're right. Oftentimes these are conversion parts, when we're trying to work on conversions. So Tom, why don't you and Joe talk a little bit about the sampling and testing process and how that works for a PM part? Like, how do we, we don't do necessarily prototyping where we have, what do you call it? Soft tools.
Yeah.
The process is a little different with PM. Yeah. So if you guys want to kind of talk about that.
Yeah. Well, one of the first things is and Tom's usually involved in this stage of it is the material side. I mean, right out of the blocks, you have to come up with what the customer needs from a material standpoint.
And you look at presently what they're using and what what is important to them, whether it's an elongation issue or whether it's tensile strength, and you try to then find a material that's going to work best for their application at that point.
And from there, we have to also then look at their interaction with the other components. You know, is it under a static load? Is it a wear characteristic where it have to be slipping by something? And that's when we have to then turn around and look, do we have to lubricate it in some manner, potentially, in cases as well. But from there, as you said, we don't have what's known as a soft tool in many other processes, whether it be stamping or plastics. They don't really exist for us, or a tool for us is basically a production tool. So the way we kind of get around that is we will produce what we jokingly call a hockey puck. It's a slug of whatever material we've come up with is the options. And sometimes it's more than one material. We'll sometimes pick 2 or 3 that we'll then either give to the customer and the customer will machine, or we'll machine it for the customer. And then a lot of times we'll bring it back because Tom will want to have it go back through and have any machining stresses relieved on that. So we'll put it back through our furnaces again. And then the customer can test that from that standpoint. One of the sidebars of that you get into is the part traditionally doesn't perform exactly the same, but it's close enough to what the production tool would provide that it at least gives them a jump-off point to go, they've got the safety factor involved in that case. It usually performs, you say, a little bit lower?
The production part generally seems to do better than the machine part.
The machine part, okay.
From there, you know, we've got instances where we do have some customers that we've had the luxury of being able to grab a tool that we may have had in-house that's close enough to a functional form for them. And most of those are the rounds, but we've had occasions that we've had the sprockets and things like that that we just happen to have something available to us that the customer could at least test that version of the thing.
Okay.
And so you might get lucky from that aspect. But in order to actually make a part and sample a part, you have to cut a tool. And that tool is, though we may be able to cut it out of a milder steel or something like that rather than a carbide, it's still a production part.
Right. And, you know, when we're talking about the slugs or the pucks that you mentioned, typically we're only talking a half a dozen to 20, right? Like we're not talking, you know, you start to get into higher quantities, Joe, it starts to make more sense to just say, all right, let's tool these guys up and let's work off tools, right?
Yeah, our general rule of thumb is usually you get to about 25 parts. And by the time you buy the slugs, you machine them, you've come up to the cost of what a tool usually costs. And the only thing at that point you're saving is whatever little bit of time difference, and you're usually talking a week or two. Right. That machining out of a puck to building a tool and making a part is your difference. So it's where the prototyping we're talking about is the one-offs. They want a customer wants to get maybe 5 prototypes built or 10 prototypes built. That makes sense to do a machined out of a hockey puck.
Okay.
You get beyond that, then your costs start to get driven up so much that it doesn't make practical sense.
Right. Okay. Well, we've kind of touched on, you know, that early involvement helping with material selection, but is there anything we want to add in there on as far as the material side goes?
Well, you go on the backside of it, and these guys have gotten heavily involved in that side of the thing is the testing. I mean, we got to know what the customer is going to test to. And I'm sure you guys have instances that we've run into of late that if you don't know what the customer's end tests are, you can build these all you want and it doesn't do you any good. You're just sending something to them and then they're going to bust them up. So it's best if we know what they want to test to as well.
So, you know, I think we've touched on, you know, a lot of the bullet points that we had. Let's kind of go back and just summarize now how important it is to get, you know, your PM manufacturer involved early. You know, just again, we're talking cost savings to, you know, tool wear. Let's just kind of go through and summarize things. Doug, do you want to kind of just kick us off there?
Yeah, I mean, what's important is, I mentioned, getting that tool design right the first time is critical. I mean, the tools, they can be costly. So, getting a design that works for the customer and it's something that we can manufacture helps get that tool design right the first time.
Mm-hmm. Phil?
Yeah, I mean, what Doug had said too. I mean, the grand scheme of the whole thing is to get involved as early as possible, obviously to save time, money, and trying to get into production with the customer as soon as possible. Not only to make sure that they get the part that they want, but get the part that we can produce without any issues. That's the main goal. I mean, you can always take on parts where you're kind of iffy if that's what you think. We don't do that. We want to make sure that we have a robust production process to satisfy the customer's needs.
Yeah.
And that's the best way to do it.
Yeah. I mean, I guess, Phil, the goal is oftentimes we're trying to fix a problem or trying to save the money. And so, I mean, at the end of the day, we want to provide, a robust, a part that's going to work well for them. We want to fix that problem, whatever that problem may be.
Could be from just not being able to get parts to having problems with the part that they have, and maybe they didn't get a chance to do that with the supplier they're working with now. So it makes a big difference.
Yeah, and it could even be just the poor material selection initially, right, Tom?
Simple.
I mean, you could maybe help a customer out by getting involved early. Maybe they had the wrong material chosen from the start, and it's simply just a material change.
Yeah, correct. And not only that, getting in early might save them money because we may be able to suggest a material that saves steps for them down the line too. For instance, a cinder hardening material versus something that you have to go out and quench and temper, especially if you have some tight tolerances involved. It's a little, it's a little easier to control some of those finish tolerances doing something like that. So, there's little things you have to kind of really understand what the customer's needs are and try and tailor what you're doing, tooling, material, process, all to their needs.
Right. And even all the way to the finishes at the end, right, Tom? I mean, if it's a part that needs so many hours of salt spray,
correct.
Well, there's a few options we have, and we got to try to fit them into that correct option from the start.
Yeah, and also trying to pick the material that you guys use for machining purposes if there's machining that's involved. I mean, there's a lot to it. There's just so many different aspects, different avenues.
Yeah, a lot of times we try to think of a part as it's a net shape out of the tool. There are instances that no matter what we do or in any process, you can't get it net shape and you're going to have to come back and do machining. That's when the material becomes an even bigger factor because it has to be machinable at that point.
Yeah, that's where we really try to attempt to be an extension of the customer, almost as an internal supplier to them that way. So we are involved in early, and they will talk to us and let us know exactly what they need.
Yeah. Yeah, and oftentimes when you call Atlas, or if we're working on a part, I mean, these are the people on the other side of the line, the other side of the team's call. I mean, these are the folks you'll be working with, and we really want to be, just like Tom said, just almost like we're in the cubicle or at the desk or in the office beside you, even though we're here in Western Pennsylvania and you might be, in Michigan, or you might be in Illinois, or wherever you may be. We want to be like we're right beside you. Yeah. All right.
That it?
I think that is, Joe.
Okay.
Joe, the only thing we didn't mention are these new fancy cups we got here.
Yes.
I'll tell you what.
We'll have to give it
Ann
to
has
Ann.
really done a nice job with this. And I think this is some great swag. What do you think?
And I think this abuse is perfect.
I wouldn't be surprised, Joe, if people watch this and they're emailing us asking, hey, how do I get me one of those PM blend cups? What do you think?
I hope they do.
I hope so, too.
Just to get in.
Yeah. And I think our supplier hopes they do too. So I want to thank you for watching today, episode 5. I want to thank Doug, Tom, Phil for joining us today, and hope you enjoyed it. And please do follow our socials.